Hello, everyone, and welcome to this study session. Thanks very much for joining us today. So, hello, everyone. Hello. Yeah, so thanks very much for joining Yusuf, and thanks very much, everyone, for joining us today. So, today is the start of a new series that we're starting in the AWS Security User Group West Africa. So we're going to be starting a new study group that's going to be focusing on different aspects of AWS security. And the team has been called Study and Win a Prize. And 1 minute, I think that we have Tolu on the line also. Apologies, just let me check. Hello, Tolu, how are you doing? Hello, can you hear me, Tolu?
Yes, good evening. Good evening.
Hello, hi.
Hi, good evening.
Yeah.
Hello, everyone. Welcome.
Yeah. So, hey, thanks very much for joining us. So, what exactly is it that we have today? So, I'll let you go ahead and with any introduction or any housekeeping that you want to do, and then we can get started with the study itself.
Okay. Yes. Thank you, Mr. David. Hi, everyone. Good afternoon. I can see Yusuf, Nod, Nijita. So, what I want us to quickly do is to introduce ourselves. So, I will go first. Like Mr. David said, my name is Tulokba Deleke, and I am a member of AWS Security User Group West Africa. And yes, we have Mr. David Okeyode, and he's also a member of the AWS User Group. So I know a lot of us here are, trying to prepare for one of our exams, maybe the security going deep into the professional part of our exam. So what I want you to do right now is to drop. Yes, Yusuf have started. Just want us to follow the step Yusuf have placed before us. Your name, where you're joining us from, just drop it on the chat, and then Mr. David can take it up from there. Thank you, everyone. Welcome once again.
Yeah, thanks very much for that, Tolu. That's awesome. So, and also, like I can see, we've always have the issue of internet connection to deal with. So I've had to switch off my video myself today, again due to some internet connectivity issues that I was having earlier. So to keep things nice. So yeah. Okay. So while everyone is dropping that information, so thanks very much for sharing that. So let's get started with the study for today, because I won't like to keep everyone too long. So what we're going to be looking at, we're going to be looking at some basic information around just AWS security, and also some information around entry points on AWS. So let's have a look at some of these information. So thanks very much again. Keep the information coming. Thanks very much for dropping the information, and we'll highlight them as you drop the information. Okay, so let's get started. So also just a quick reminder that we have another session that will be happening tomorrow. So I'll be speaking on securing web applications, web application environments on AWS. So same time tomorrow, and we have CJ that will be moderating that session. So before we go too far, let's get the right slides on. Let's make sure we're all good. Okay, got my slides now, and let's go ahead and do my slides again. So I think I got the wrong slides the first time. Okay, so you should be able to see my slides now, right? Is it coming through?
Yes, absolutely. We can see that.
Awesome. So let's get started. So I'll try to go very quickly. So we get started with security on AWS first of all. So what are we going to look at? Just going to introduce just security concepts in AWS, so an overview of security, the concept of shared responsibility model. When we talk about security, it's important to understand that concept. We'll look at incident response in AWS and some of the things that we need to keep in mind when we're thinking about incident response. We'll look at some information around DevOps with security engineering. So this will be module number 1. Module number 2 will get much more into entry point on AWS. So let's get started with this module, security in the AWS cloud. So one of the things that's very important to know, apologies. Again, apologies. Slide misinformation there. So let's do that again. That should be better now. Okay. So one of the things that it's very important to highlight when we talk about security, what are the objectives that we're trying to achieve in any security project that we're doing? So typically we're trying to achieve the objective of confidentiality. So what we want to ensure is that only people that should have access to a system or only people that should have access to a data has access to that data. So that is confidentiality. We want to ensure integrity, which means we want to protect against manipulation, right? We want to have consistency. Whatever data that we stored should be the same data that we are retrieving. So it should not be something that someone has manipulated or modified that we are retrieving. So integrity is very important when we're talking about security objectives, and availability is a final security objective that we want to achieve. So an availability is really talking about, we want to ensure that our AWS services and the applications that we're hosting on AWS are available to the users that should have access to them. So let's have a look at some of these concepts in much more details. So when we're talking about cloud platforms like AWS, right? So there are certain things that we need to look at when we're talking about security. And what I call them is I call them the pillars of AWS security in the cloud. And there are 5 pillars that you can see that I mentioned on the screen. So for example, we have the pillar of visibility, we have the pillar of auditability, controllability, agility, and automation. Those are 5 important pillars. In order for you to be able to implement adequate security in the AWS cloud, you need these 5 pillars. So visibility is very straightforward. How can we protect something that we don't even know about? So we have to have visibility. Auditability is also important. We need to ensure that we can trace things. Who made this change? When was this change made? How did this change happen? It's important. Controllability is another important aspect of that. Maybe in your organization, you have a compliance policy where you have to be in control of your encryption keys. AWS has capabilities with KMS that allows us to use customer managed keys, right? We have the pillar of agility, which means we have to be able to respond to changing requirements. So that's important. So this is one of the main differences between just traditional security on premises and security in a cloud platform like AWS. Ability to respond to changing requirements in a quicker way. And automation. The only way to achieve security properly in the cloud is to do it in an automatic way. So let me have a quick look and see and make sure that everything is all good. So everything looking all good. So, and by the way, Tolu, in case there's any question or anything that comes up that I've missed, because when I'm sharing my screen, I'm not seeing like what's going on behind the scenes. So feel free to jump in at any time, to bring things back. So okay. Anytime that you want to.
Okay, noted. All right.
Yeah. Okay, so I'll carry on very quickly with this. So visibility, I talked about that earlier. I said visibility is we need to understand what do we have implemented on AWS, right? So we need to understand that we have to put processes in place to identify the services that are being used by our teams, but then we have to go beyond identifying the services that our teams are using. So for example, how many AWS accounts do we have in our organization, right? There are situations that I've been in where a business unit have gone to use corporate credit cards to sign up for AWS, and they're hosting production services on those AWS accounts, and the security team don't even know about them. So you have to put processes in place to identify your AWS accounts and identify the services that you're hosting. Auditability, I mentioned that earlier. Auditability is you have to put processes in place to collect the necessary logs. So number one, you have to make sure that logging is enabled. So that's how you get auditability. The last thing that you want to happen is you've experienced an incident. You need to investigate an incident, but you do not have any evidence to investigate the incident because you've not enabled or implemented auditability in your AWS environment. And at the very heart of auditability in AWS is a service called AWS CloudTrail. I'm sure as we go through this study series, we'll get much more details about AWS CloudTrail. We have controllability. Controllability is understanding that when we're leveraging the cloud platform like AWS, there are certain things that are in our control. There are certain things that are not in control. But the other thing that we also want to keep in mind is that the things that may not be in our direct control, there are some ways, for example, for us to be able to influence those. So what do I mean by that? Again, a good example is you have a requirement in your organization to use encryption keys that are managed by your teams. You don't want to use encryption keys that are managed by AWS. AWS Key Management Service, KMS, gives us the ability to implement something like that. And the other two pillars, we have agility and we have automation. And this is, again, very important in the cloud. You have to put in processes to automate some of our security responses, right? So if this security incident happens, you have to put in automation in place to respond to things. Responding to incidents manually, it's not going to be able to scale in the cloud. Let's move on very quickly because of time. So let's introduce very quickly the concept of AWS shared responsibility model. So this is a model that many of us have heard about before. Essentially, what that model means is we're not responsible for everything related to security in the AWS cloud. We have different levels of responsibility. AWS has responsibility for some things. We have responsibilities for some other things. But the other thing to also keep in mind is that depending on the AWS service that we're using, our responsibilities may vary. For example, if we're using AWS Infrastructure Services, maybe we're using services like EC2, Elastic Block Store EBS, or VPC, Virtual Private Cloud for our private networks. We have certain responsibility when it comes to securing those services. So for example, with EC2, we have responsibility for everything from the operating system and above. Of course, we have responsibility for protecting our data. We have the responsibility for protecting the network traffic that's communicating with our environment, right? And one of the things that we can also do is that we can add a layer of isolation or a layer of opacity between what we're responsible for and what AWS is responsible for when it comes to security of infrastructure services. So a good example of that is we're implementing maybe technologies like data integrity authentication. So maybe we're doing things like data signing, things like software signing, right? So implementing those types of technology puts an additional layer of isolation between what AWS are responsible for in terms of security and what we are responsible for. When we're talking about services like AWS Container Services, you can see here that we have less responsibilities to look after because a lot of the underlying infrastructure that's running these services are managed by AWS themselves. So AWS themselves has responsibility over the underlying infrastructure running the services. However, we still have responsibility with regards to our encryption, with regards to the firewall configuration, with regards to the network traffic protection. And of course, we can add that layer of opacity between us and AWS, again, by implementing technology like data signing and technologies like code signing and to add that extra layer of protection there. We have other services in AWS that are even further abstracted. So here we're beginning to talk about serverless services, right? So services like AWS Lambda, services like S3, services that we cannot really feel any infrastructure going on behind the scene, even though infrastructure exists, right? So, but we're really just looking after our code and our data at this point, right? But always keep in mind that extra layer of opacity can always be added. So one of the approaches that you see that many organizations will take when it comes to how they handle security responsibilities in AWS is they will create a team within their organization that's responsible for managing security services. And that team will be responsible, maybe as part of like their Cloud Center of Excellence team. Many organizations will have a Cloud Center of Excellence. Again, depending on the size of the organization, you have a Cloud Center of Excellence team, and then you have a managed services team that's responsible for different aspects of the AWS environment. But in this case, we're talking about a team that's responsible or that handles responsibilities around security, compliance, and governance. So, for example, there will be the team that will approve new CloudFormation templates that will be deployed, maybe by the development team. Maybe the team will be the ones to really approve the users or identities that are going to be created in the AWS IAM. Maybe they are the ones that are going to be reviewing the vulnerabilities of the AMIs and approving AMIs that have passed the different tests for use within the organization. So maybe they are going to be the teams that are going to be responsible for creating new AWS accounts for the different teams and making sure that the accounts are configured properly when it comes to security and compliance. So you can have a managed service organization team within your organization that takes on this responsibility and provides it as a service to the rest of your organization. So when it comes to the model, you can see how that model works. At the very bottom, we have AWS that have their own security responsibilities that they look after. Then we have a managed service organization that handles security, compliance, and governance responsibilities on behalf of the organization for AWS account. And then we have the workload owners, which are talking about the development teams, the sysadmin teams that are responsible for different workloads running on AWS. And those teams are responsible for their own workloads or their own portion of the workloads that they're running on AWS. So you have the distribution of security. So one other thing to mention is that if you have any questions, please do leave your questions in the chat window, and we're going to address the questions. And also, if you, we're going to be having a quiz at the end of this. Now, the quiz, I should say, it's not going to really be aligned with what we're discussing here today. So apologies on my part for that. I didn't get the quiz out in time, but we're still going to have a quiz, and the person that gets the top score in the quiz today, it's going to be going away with an AWS $100 credit. So make sure you pay attention all the way to the end, and make sure that you get ready, get yourself in the quiz mode, ready to go through the quiz.
Okay, Mr. David, before you continue,
yes.
Abak has a question here. He said
Yes.
you should elaborate more on the client side of the data encryption.
Okay, so let me talk about that very quickly. So when you're talking about data encryption, right, there are different approaches that people can take to that. So for example, there's, you have like AWS S3, where you have the service, right? I'll just say S3 here. And then you have something like server-side encryption, right? So you have server-side encryption, but that sort of encryption is not something that really benefits you to an extent, right? Because what that means is that AWS are encrypting your data at rest in the AWS data center. So they are encrypted at rest in the AWS data center. But client-side encryption means that before my application writes data to this S3 bucket, what I'm going to do is I'm going to encrypt that data first on the client side. So I can use any of the encryption client libraries to achieve this. I encrypt my data first before storing my data in that S3 bucket. So that way, even if somebody were to get access to this S3 bucket and they exfiltrate all the data out of that S3 bucket, they won't have access to my plain text data, because my data was encrypted using an encryption key that only my application knows about, or only my application should know about. And that way, even if AWS teams were to find a way to get access to my S3 bucket, they won't be able to access my data. Hopefully that makes sense. So that is talking about client-side encryption. Encrypt the data before you store it in the service. So that's what that means. Hopefully that answers your question. Okay. So there's no other question for now. I can move on to the next aspect. So let's move on very quickly because I'm looking at the time here. So let's have a look at some quick information around incident response. So some of you may be like me, right? When it comes to the time that you spent in IT or in tech, may probably have been involved in some incident response where maybe a system was compromised and you have to run over to that system and disconnect the system from the network. You unplug that network, that network cable, you unplug it from that system to disconnect it so that there's no lateral movement, and then you can start doing like your investigation and all that stuff. Well, when we're talking about something, an environment like AWS, there's no real cable that we can go unplug, right? So,
sorry, Mr. David. Sorry.
Okay, no problem.
Before we continue, there's like two questions on client side of the encryption that we talked about.
Okay, no problems.
So someone said that same person said, is it different from TLS V1? And then
so TLS
V1 asked, and that person is client encryption more prevalent in AWS?
So to answer like the first one, is it similar to TLS? So this is not TLS. We're not using TLS for this. So TLS is a standard that you use for encryption in transit, right? So this is not talking about that. So this is using any one of the encryption algorithms. So that could be leveraging, AES 256 or AES 128 encryption standard, or using any of these encryption standard to also encryption algorithms to encrypt your data before you store them. So this is not the same as using TLS. So TLS also leverages the same standards that you can use to do client-side encryption, but they're not the same thing. To answer that. And sorry, Tolu, can you help me with the next question, the other one?
Ugo is asking that, is client encryption more prevalent in AWS?
I would say not just in AWS, it's more prevalent in situations where you're concerned about where you need to implement a level of isolation between a provider and your data. So what that means is, for example, I'm giving Tolu my a letter to deliver to my friend, or let's say Tolu is giving me a letter to deliver to our friend, right? So Tolu is trusting me with that letter, but at the same time, Tolu is concerned that what if David opens this letter? Would David be able to read this information? So what I want to do is I'm going to scramble that letter. I'm not going to use plain text. I'm going to scramble that letter before handing it over to David, right? So that way, even if David is reading the letter, David won't get the information that I'm trying to pass across, if that makes sense. So that's sort of like situations where you look at implementing client-side encryption, where you go, okay, I know you're encrypting my data at rest, but I'm also concerned about what if somebody compromises your system and they try to read my data directly from your system. I need to encrypt from my side before I put it on your system. So that's when you use client-side encryption. Hopefully that answers the question also. Okay, so if there are no other questions, I can move on to talk about this other aspect. So when we're talking about incident response, one of the things that comes up in that conversation when we talk about incident response in regards to AWS is something called AWS Cloud Adoption Framework. And what AWS Cloud Adoption Framework is it is a set of guidance, right? It's not like a standard or anything. It's just a set of guidance provided by AWS on how to properly implement workloads on AWS. So that is what AWS Cloud Adoption Framework is. And what AWS Cloud Adoption Framework does is that it breaks the guidance down into different perspectives. And one of the perspectives that it covers is the security perspective. So in the security perspective, there are 4 components of the security perspective in AWS Cloud Adoption Framework. Component number 1 is directive. Component number 2 is preventive. So these are the 2 that I called the proactive security components in Cloud Adoption Framework. So these are proactive, right? These are helping you to prevent bad things from happening to begin with, or to make sure that you do your security design and architecture properly. Then you have the 2 other components, which is the detective component and the responsive component. And these are the components that I call the reactive component, right? And the work of this component is to be able to react, to respond to issues that happens within our environment. If we've missed something out, maybe in terms of the directive or preventive, how do we detect it as quickly as possible and respond to fix it and stop it as quickly as possible? That is incident response, and that falls in the detective and responsive component of the Cloud Adoption Framework, the security perspective. So let's have a look at some thoughts. Yes, it's true that we don't have any cable that we can disconnect in AWS, right? Whenever an incident happens. However, there are other things that we can do. For example, we can move a system from a public subnet into an isolated subnet. We can modify the security group of a system. So, for example, if we need to do forensics on an EC2 instance, we can take a snapshot of that EC2 instance. If we need the memory state for investigation, we can isolate that instance. Maybe we move it again into something like a forensic subnet, where we can do our investigation on that instance and look at what is happening there, right? So there are different ways for us to still do incident response on AWS, even though we have no cables to unplug, so to speak. So let's move on. So yeah, some common incidents that you may get in terms of security incidents on AWS, or some common incidents have to do with compromised user credentials. So that is very popular. So maybe due to an insecure password, maybe an insecure access policies, or a very common one is people that leave the business. I've seen this happen multiple times. People leave a business, they have different credentials that they've created in AWS IAM or different access keys that are not disabled, and they can still use those access keys and those credentials to see access the environment, even though they've left the organization, right? So, and that includes making sure that you have processes in place to make sure that whenever a user leaves your organization, you're disabling those identities that they may have created, you're deactivating those access keys that they may have created in your IAM. So another category of common incident is insufficient data integrity. So that's talking about where somebody is able to modify data or delete sensitive data, whether in transit or at rest. So those are common incident types again. Another common incident type is overly permissive access. So some of this we've seen with Open S3 buckets, some of it with Elasticsearch databases on AWS that are made public or with default credentials. So Elasticsearch, I think they recently changed the name to OpenSearch database. So it's no longer called Elasticsearch. But anyways, so what do we look at to detect incidents on AWS? Well, there are different signals, there are different sources that we can monitor to detect incidents in AWS. So we can look at logs and monitors to start with. So when we're talking about logs, we're talking about looking at things like CloudTrail logs, looking at things like your S3 access logs, right? Looking at things like our VPC flow logs. So we're looking at our VPC flow logs. So that could even be EC2 logs, for example. So maybe you have a CloudWatch agent installed on an EC2 instance and you're collecting the logs. So you're analyzing all these logs from CloudTrail, S3, VPC, EC2 to identify indicators that something has been compromised within your environment. So other signals and sources that you can look at billing activity. This one can be very interesting. So for example, you're only deploying services or resources in 2 AWS regions. All of a sudden, you're seeing services being deployed in regions that you typically don't use in your organization. That may be an indication of something not being right, something being compromised, right? So maybe, for example, what you want to do is you want to set alarms in your organization for regions that you're not using whenever resources are deployed into those regions. Another signal or sources that we can look at for incident indication are threat intelligence services. So here we're talking about services like Guard Duty, services like Amazon Macy. So these are services that do a bit of threat intelligence already. And what we can do in this sort of cases is we can get those issues that are detected in those services, and we can investigate them further. So a very interesting one that many people forget about is also AWS support. That's very important because in some cases, AWS support may identify abusive or malicious activity in your AWS account. And what they're going to do is that they're going to notify you of abusive or malicious activity that they've detected. But the thing that you have to have in place is you need to make sure that your contact information is set correctly. Make sure your contact information is set correctly. The last thing that you want is to set a contact information for someone that has left the company. AWS support are trying to contact you to notify you of an incident, but that's not going to anyone that can respond to that. So make sure your contact info is set correctly. And another source that you can look at for incident indication is ad hoc contacts. What that means is users within your organization, or maybe even users of your services, maybe external users of your services may notice some issues in terms of how you've configured your services or how your application is running, and they want to notify you. You have to have a window that they can use to contact you. So maybe that's having a publicly available email address. You publicize an email address to say, if you notice any issues with any of our system, send us an email, right? Or maybe to your internal team, maybe you have like a ticketing system, raise this ticket to the IT security team or to the cloud security team if you notice any issues within our environment, right? So these are the different sources that we can look at. Very quickly, let's look at DevOps with security engineering. So,
Mr. David, before we move on, please.
Hello. Yes.
Yes.
Yes, please go ahead. Sorry. Oh, I'm not sure if we have Tolu there. Oh, I think that we may. I think Tolu's. Oh, I think that Tolu's internet connection may have dropped a little bit because I can see it showing as red. So, okay, I'll wait for Tolu to come back. Oh, I think Tolu is back now. Hello, Tolu. Can you hear me now? Oh, I think it dropped again. Okay, so I think
yes, I can hear you now.
Oh, awesome. Sorry, you were saying something before your internet connection dropped.
Yes. Yusuf asked the question, is AWS Cloud Adoption Framework, AWS Well Architected Framework?
Okay. very, very interesting question. So, Cloud Adoption Framework and Architected Framework. So, Well Architected Framework is how to best architect your AWS services. So that is Well Architected Framework. Cloud Adoption Framework is more towards migration of services, I'll say. So it's more towards migration of services. You're migrating services from on-premises to the cloud or from another cloud to AWS cloud. So it's talking about some of the components that you need to be aware of as you do that migration. Whereas well-architected framework is just a set of standard design practices when you're just designing services on AWS. Okay, so I'll move on if that's okay. So let's move on very quickly so that we have time for our quiz at the end. So we said we're going to look at DevOps with security engineering very quickly. So DevOps with security engineering. So DevOps is a continuous delivery model that's repeatable, it's reliable, it's stable, resilient, and secure. More delivery model for delivering services to production. And there are three aspects to DevOps. You have the people aspect, the process aspect, and the tools aspect. So, and they usually have to come in that order. People over process over tools. When it comes to DevOps, you don't want to mess things up. So what this says, the process should dictate the tools, not the other way around. And you have to have the right team culture that fosters collaboration. So there has to be a collaborative culture in your organization if you're going to get the benefit of DevOps. But where does security comes in when it comes to this? So let's have a quick look at some of this. So when it comes to the process aspect of DevOps, there are three main components that are involved in the process aspect of DevOps. We have continuous integration, continuous delivery, continuous monitoring, and improvement. Excuse me, right? But what we want to also begin to do is that we want to start leveraging this to automate security within our organization. So that's the whole point of this, right? And practices like infrastructure as code enables us to be able to implement that in a much more streamlined way in AWS. Leveraging things like CloudFormation template allows us to be able to implement that in a much more streamlined way. So for example, because I'm defining my infrastructure as code, I can assess the security of that infrastructure before I deploy or provision that infrastructure. So I can use different tools, maybe tools like Chekhov or other tools that are out there to assess the security of that template or the security of the infrastructure that I'm about to deploy before I deploy it. So that's one of the advantages of this. And then we can implement that into a DevOps workflow. Is what this is talking about. So the whole idea behind that is we want to start integrating security as part of our DevOps processes going forward. So we're talking about implementing things like threat modeling, security testing, and security validation all across the process. And also, even before deployment, we want to have some security validation across all our pipeline before we do deployment. So moving on very quickly, so looking at the aspect of integrating threat modeling as part of our security practices. So threat modeling, the whole idea behind threat modeling is being able to identify issues before we start writing any code. That's the idea. So what's the software architecture that you're looking to create? So as a security person, you're in the room with your developers. So tell me more about the architecture. Okay, let's trace the data flow of this architecture. So users are going to submit data through this front end, okay? And then that data is going to be sent from the front end to the back end and stored. Okay, that's interesting. So let's trace that data flow. What if someone manipulates that data, right? What if someone sends a data that's an injection attack, right? Do you have any validation in place that's going to validate that data before you accept it from the client in the first place, right? Or before the front end submits that data to the back end? Is there any validation in place? That is threat modeling. Identify security flaws or security weaknesses in your architecture and your design before you write any code. And there are different methodologies that organizations use to implement, threat modeling. A common one is using the STRIDE framework. And STRIDE stands for what we have on the screen: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. The whole idea behind that is look at your software architecture, trace the data path, trace the data flow. And then what you do is you identify weaknesses in that architecture and that design, and you map those weaknesses to the different threats. So you say this weakness is mapped as a spoofing threat. This weakness is mapped as a tampering threat. This weakness is mapped as a denial of service threat. And then you provide guidance to your development team as to, in order to mitigate against spoofing, you need to make sure that you validate the identity that's going to be passing that data. In order to mitigate against tampering, you need to make sure that you're validating the integrity of what's being sent or what's being read before you send that on. In terms of repudiation, you need to make sure that you confirm. In terms of information disclosure, you need to make sure that you have practices like encryption to ensure confidentiality. So that's essentially what this model is talking about, right? So again, look at your software design and architecture, map them against these different threats, provide guidance to your development teams on how they can mitigate against those threats. So here's an example of that. So here we have an example of epics that are built from different user stories. Again, this maps to like the AWS Cloud Adoption Framework. And this is really just defining different epics, again, mapped around different security frameworks. So let's move on very quickly in the interest of time. So I'm looking at, we only have a few more minutes and I want to get to the quiz. And I know that you're looking to get to the quiz also, but I also want to make sure that we at least cover some interesting parts with regards to the entry point also. So penetration testing on AWS. Can you do penetration testing on AWS? Yes. The answer to that is yes. However, you need to be very careful, right? There are certain AWS services that you're using that do not require you to submit approval, to submit a request for approval to AWS before you perform penetration tests, right? So keep that in mind, that there are some services that do not require you. However, the fact that these services do not require you doesn't mean that you should go crazy and start doing all types of penetration tests against these services. That's not what it is talking about. For example, you cannot at any point perform a distributed denial of service attack against any AWS service. That's not allowed, no matter what, right? So the reason why that's not allowed is that could potentially impact other customers that are using the same services. So that's not allowed in any way, shape, or form. Also, when we're talking about penetration testing, the scope is really limited to pen testing your services and your applications. So keep that in mind. Not necessarily pen testing AWS themselves, but pen testing your own services and pen testing your own applications that are using these services. That's what that is talking about. Okay. So I'm looking at the time now, and I think I want to get to the next module very quickly. So let's get to the next module. I'll introduce the next module, and I think we can pick it up from tomorrow. So
yes, Mr. David, sorry, before we continue.
Oh, sorry, Tolu.
This will be on the...
Oh, sorry, Tolu. The internet connection dropped, but I can hear you now. Yes, please go ahead.
Okay, a lot of people are asking the slide, the videos. I think we need to let them know where and rewatch it.
Oh, okay, yes. So the video, what we're currently sharing live is actually also on the YouTube. So if you're yet to like the YouTube channel, please go ahead and like the video and also subscribe to the YouTube channel, so you can always go back and watch the videos. So with regards to the slides, there's still a lot of work in progress. What I can do is that once I tidy up a lot of the slides, I can share it on our community GitHub, or on our community publication, so that you can also get access to the slides. So, but at the moment, they're currently still a work in progress. So I'm still tidying up some things. So, but I'm definitely happy to share them. So again, follow the community publication, and when we share them, you'll be able to get them from there. Okay. So let me just quickly introduce the next module, and then we'll have a quiz. So again, get ready, get ready, get ready. Someone is going to be winning $100 US. So, but let's get started with the next module very quickly. So module number 2, let's look at identifying entry point on AWS. And what we're going to be looking at in this module is what are the different ways to access the AWS platform, understanding AWS IAM policies and how they work, the IAM permissions boundary on AWS, so we'll try to understand that, IAM access analyzer on AWS, multi-factor authentication when it comes to identity and access on AWS, and then some introduction to CloudTrail. I think that today I'll probably just stop when we get to the understanding IAM policies bit so that we can do the quiz. So identifying entry points on AWS. So let's quickly talk about that very quickly. So first of all, interacting with AWS. There are different ways that we can use to interact with AWS. So we can interact with AWS using the management console. We can interact with AWS using the AWS CLI, using AWS SDK, or using any other another service to interact with the AWS APIs. So AWS services are all exposed as APIs. So a lot of AWS services are regional. They're exposed in different regions, and there's an API interface that we're talking to. So even if you're using CLI, you're talking to an API. You're using the SDK, you're talking to an API. You're using Management Console, you're talking to an API. So the way that works in terms of the request flow is that your endpoint, again, using CLI, Management Console, SDKs, you're interacting with the API endpoint. Authentication happens, authentication and authorization happens with AWS IAM, and at the same time, login happens in AWS CloudTrail. So that's important. So, and then before access is granted to the actual AWS API that you're trying to call. Another thing to keep in mind when we talk about the entry point is that AWS services, a lot of services are regional services. And what that means is that they expose APIs in different regions. So for example, here you have the CloudTrail API endpoint in Sao Paulo in Brazil. So you can see that it has the name of the service CloudTrail dot the name of the region, SA East 1 dot Amazon AWS.com, and that's the API endpoint for CloudTrail in the Sao Paulo region of AWS. And it's the same for many of these other services. There are other services that are not regional. So services like IAM is not regional. Services like CloudFront they are not regional services. Those are global services. So you won't necessarily find regional endpoints for those services. But one of the good things about the API request, making API requests to this AWS API endpoint, is that if you're leveraging AWS tools to interact with these APIs, it has security implemented by default. So, and one of the security is around integrity. It signs every API request. So if you're using AWS SDK, AWS CLI, AWS Management Console, your API requests are signed before they are sent over to the API endpoint. And then the API endpoint can use the signature in the request to validate the endpoint. To validate the request before processing it. So it can use that to verify the identity, can use the signature to verify the identity. It can use the signature to make sure that it's not been tampered with in transit. Somebody has not modified that request in transit. It can also use that to prevent replay attack. So a lot of AWS APIs, and they have a limit of about 5 minutes. So if there's a delay of about 5 minutes in terms of the time of the request, it's going to drop that request. It's not going to accept that request. So again, that's a way to prevent from replay attack. So we've almost run out of time here. So what I'm going to do is we're going to pause there for today. So tomorrow, before we talk about securing web applications, I'm going to conclude this module. But let's pause there for today. So let's get to the quiz that I know that many of you are waiting for already. So let's get to that. How about we get to that? What do you think, Tolu?
Absolutely.
Or do we have any questions addressed before we go for the quiz?
From David.
Oh, sorry, I missed what you said now.
One question from David. David's the question here. Just one.
Oh, okay.
what kind of external security solutions can we deploy within our security process for the proactive aspect of the CAF security perspective?
So for the proactive aspect of security, so what kind of external security solutions? Well, actually, so when we talk about like the cloud, when we talk about like the proactive and the aspect regarding the proactive, a lot of those have to do with architecture and design versus really implementing services or implementing external services. So, for example, a lot of that has to do with making sure you're doing least privilege. Remember that cloud adoption framework is just a set of guidance, right? It's like, have you set authentication, and are you making sure that you're only granting the privileges that you need to be granting? Have you implemented encryption, and have you made sure that only the services that need access to the encryption keys have access to the encryption keys? So essentially, it's putting in a lot of security best practices and design principles in place versus implementing services and all the other stuff. So when it comes to like a lot of the services that Cloud Adoption Framework recommends, a lot of the services are AWS services because it's AWS Cloud Adoption Framework. But what you can do is if you have like a third-party provider that you are aligned with, you can substitute some of the AWS services with your third-party service. So for example, maybe instead of using an AWS firewall or just network security groups, maybe you're substituting that for maybe a Palo Alto firewall or some other firewall that you're using, those sort of stuff, right? So, but it's more about implementing those best practices versus the services themselves. Okay, so is there any other question? Otherwise, what I'm going to do is I'm going to start a Kahoot quiz. And I'm going to do a classic mode. And what I'm going to do is I'm going to put a link in the chat window for a Kahoot quiz. So remember that the questions don't necessarily map to what we talked about today. So we'll try to fix that going forward, but apologies. Tolu and myself are very, very busy people. So so I put the link. Yeah, so I understand that it's very busy. So I put the link in the chat window. So if you click the link in the chat window, that will take you to a Kahoot quiz. So just waiting to see people joining. So look in the chat window again. Ladies and gentlemen, look in the chat window. Okay, so we got only Bolaji that's joined the Kahoot. So again, go to www.kahoot.it and put in the PIN number 518445, or you can use the link in the chat window. So one of the other of the two. So www.kahoot.it and the PIN. Awesome. Now we have more people joining now. Okay, we'll need to proceed now because we don't have all day and we already gone past about 1 hour. We'd like to get this done, get the prize out to someone, and let's move on. Okay, so we're going to go ahead and we're going to move on. So let's go ahead and start. So here is the first question for today. Which data is not used by guard duty to detect unusual and unexpected behavior? So this is testing your guard duty knowledge, where all security people. Which data is not used by guard duty to detect unusual and unexpected behavior? Remember, you have $100 AWS credits on the line here. So let's see. Let's see, let's see, let's see, let's see, let's see. Okay, more answers now. And let's see. Okay, so the answer to that is not used. CloudWatch logs. Oh no, this is interesting. Definitely, we need to beef up our AWS security knowledge. So, guard duty looks at VPC flow logs. It looks at CloudTrail logs. It looks at DNS logs. It does not look at CloudWatch logs to detect unusual incidents in our AWS environment. So it's 0 for everyone. So let's see. Next question. What captures and stores network traffic information in and out of network interfaces from instances within your VPC? Let's see. Let's see how we're doing. And we have a few more answers there. Okay, so the answer is VPC flow logs, and 10 people got that correctly. But let's see who is currently topping the board. So we have Abigail currently topping the board. So well done. So let's see if you're able to maintain that in the next question. A low severity threat in AWS guard duty has a score value between dash and dash. Oof, this one is it's a detailed one, right? It tests your knowledge of guard duty in much more details. So when something is marked as low severity in guard duty, what is the score that it usually has, right? For something to be marked as low severity. Almost there. Two more questions after this for 100 US dollars credit. And the answer to that is 0.1 to 3.9, which makes sense because that's the lowest score that's available there. So that is what is marked as low severity in guard duty. And we have 3 people that got that correctly. And let's see any changes. And we still got Abigail still leading. So well done. So next question, number 4. What happens when a user suspends the AWS guard duty service? So the answer to that is existing findings will remain in the console, and we have only one person that got that correctly. So let's see the leaderboard. Oh, wow, we got Frank moved all the way to the top. So we got Frank, Abigail, and Unjita, top three. So still one more question to go. One more question to go. So let's go to that. Number 5. An AWS guard duty summary of the finding contains which information? So when you see a finding in AWS guard duty, which information, which one of the information here will you find there? So this is the final one. And we'll see who will be leaving today with $100 AWS credits. There's a lot of labs that you can do with $100 worth of credits. And the answer is all of the items. So finding type, severity, and account ID. So 9 people got that correctly. But let's look at our final leaderboard. So let's see. Number 3, we have Peter Pan. Well done, Peter Pan. Number 2, we have Prabhu. Well done, Prabhu. And number 1, we have Unjita. We have a new leader. We have Frank and Bolaji. We have Frank and Bolaji. So thanks very much for participating in that. So what we're going to do, apologies for that. So what we're going to do is we're going to, so Unjita, I'm just trying to get to my screen. Here we go. So finally, okay. So Unjita, if you put your email address in the chat window, and then we can get your credit to you. So put your email address in the chat window and we'll get credit over to you. So Ms. Tolu, anything that you want to add before we call it a day today?
No, nothing from my end. Just a reminder that we have a session tomorrow.
Yeah, that's so true. We do have a session tomorrow, and again, we'll just pick things up from there. Apologies for going 10 minutes late today. We did start a little bit later today. So, but we're going to pick things up from there tomorrow. So, Unjita, do not forget, please do put your email, send your email address, and put your email in the chat window or something so we can get your voucher over to you. So make sure you do that. Otherwise, we're not going to be able to get your voucher over to you. So that is very important. Okay. So with that being said, thanks very much, everyone. Yeah, so Tolu asked the question. So I'll let Tolu answer that question for you. So Tolu is asking a question in the chat window. Tolu.
Why not you join us tomorrow to know that? Join us tomorrow to get that information because we are namesake. Join us tomorrow and you will definitely get that information.
Yeah, so we'll keep that as a suspense there. So you get that tomorrow. So, and by the way, all I would just say is the title of our session probably is giving you a pointer to what is going on, right? So if you look at it, study and do something. So anyways, okay. So thanks very much again, everyone, for joining. So see you tomorrow. Have a lovely, lovely evening. Mr. Luke, thanks very much for joining us today. Thanks very much for moderating today's session. It's been amazing. So see you all tomorrow. Have a lovely time. Bye for now.
Bye, guys. Bye, Gabriel. Bye, Tolu. Bye, Dikmeji. And congratulations once again, Unjita.
Yeah.